The force needed to extend a spring will be equal to the product of the spring constant and extension of the spring. Remember that deformations like extensions only happen when we have multiple forces acting on an object. For example, to stretch a spring, we would want forces pulling the spring from either end. Then we can relate the extension of the spring to the force we apply using the equation force equals spring constant multiplied by the extension. In symbol form, this is F equals K times E. Here, F is the strength of the force we apply to the spring. Usually with extensions, the two forces applied will have the same magnitude. So F could represent either of these forces. In an exam question though, it will always be clear what value to use for F in this equation. Then K is the spring constant, a measure of how stiff the spring is. And lastly, E is the extension of the spring. To find this, we compare the length of the spring before and after we apply the forces, and then find the difference between the two. This is the extension. Make sure you understand that E is not just the length of the extended spring, as this is a common mistake students make. It's specifically this difference we use in the equation. So what units will we use? Well, we know that forces are measured in newtons, and since extension is a type of length, we'll measure that in meters. Then we can also use this to deduce that the units of a spring constant are newtons divided by meters. To find a spring constant, we would divide a force in newtons by an extension in meters, giving these units. Also, it's important to remember that this equation only holds if the force is below the spring's limit of proportionality, though we'll see what this means elsewhere. In an exam, you can assume it's okay to use this equation unless you are given information to suggest otherwise. Let's try using this equation in an example. During an experiment, a 15 Newton weight is hung from a spring attached to a clamp stand. The spring extends by 25 centimetres. Calculate the spring constant of the spring. Now, this is actually a common way of measuring spring constant. You may have done an experiment like this one in the classroom. So step 1 is to write down the key information and check the units. So first we're told that a force of 15 newtons was being used, as this is the weight that was hung from the spring. Then we're told the extension was 25 centimetres. But our equation needed the extension to be in metres. So we should convert this to 0.25 metres. Now we want to use this information to calculate the spring constant of the spring. So step 2 is to rearrange the force extension equation to make the spring constant the subject, where we'll be starting with force equals spring constant multiplied by extension. We can get spring constant on its own by dividing both sides by extension. This gives us force over extension on the left and then spring constant on the right. And finally, step 3 is to substitute the values into the rearranged equation to find the spring constant. If we flip around the equation from the previous step, we have spring constant is equal to the force divided by the extension. So if we substitute the values given in the question, we'll find that the spring constant of this spring will be 15 newtons divided by 0.25 metres, which is 60 newtons per metre. Remember that spring constant is a property of the spring. So if we were to hang different weights off the spring for different extensions, we'd still get the same result from this calculation. But what about compressions, where the length of an object decreases instead of increases? Can we do a similar calculation for those? the same equation can be used for compressions of springs, with compression used instead of extension. This time we're starting with a long spring and shortening it using two forces directed towards each other. Here the equation we use is force equals spring constant times by compression. It's the same as the equation we used before, just with compression instead of extension. In symbol form, this will still be written as F equals KE. F is still the magnitude of either force we apply to the spring, and K is the same spring constant that we would use in an extension calculation. Then E is the difference in length again, between the spring with and without the forces applied. It's just like the extension equation, but we're measuring the decrease in length rather than the increase. We'd also use the same units as the previous equation. Newtons for the force, newtons per metre for the spring constant, and metres for E, in this case the compression. And also like the extension equation, this equation only holds if the force is below the spring's limit of proportionality.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!